A function in C is a self-contained block of code that performs a specific task. A function can return a value, or it doesn't have to return a value. If a function returns a value, that value has to have a data type associated with this. If the function does not return anything, then we have this keyword called void. Void signifies that the function does not return anything. The reason why we're using function is because we want to organize and modularize code, making it easy to read, understand, and maintain. The biggest benefits for having function is we can reuse code without having to write them in a procedural way. This is an example of a function call is leap year, which takes on a parameters list of one parameters called year of type integer, and this entire function returns an integer. You have to have open curly and closing curly braces. Since this function returns something, you have to have a return keyword proceeding by a statement with a semicolon. On the bottom here, we have function invocation. This invocation calls the function, which returns something, and this something must be an integer. Since the conditional is either true or false, which is a Boolean, which is also 0 and 1. In C++ and C, when this value is 0, that value is false. Anything else is true. The return type of this leap year is a valid conditional trigger. If true, this will be printed. If not, this will be printed. Let's look at void function. This is the type of function that does not return anything. So you can consider this void as some sort of label that tells the developer, hey, this function does not return anything. You do not need to have any return at the end. Having it will be incorrect. The invocation of this void function is the same as if you're invoking any other types of non-void function by calling the function's signature and a parameters list. In this case, the menu function signature does not have a parameters list. Let's look at more of function invocation. As stated, the function is a self-contained block of code that performs a specific task. Let's say we have two functions, function 1 and function 2. Your main code has two invocations. The first one invokes function 1, the second one invokes function 2. As soon as a function is invoked, your entire flow of execution goes into this function and starts to evaluate the statement it has and return. If there's no return, your flow of control goes back and continue on and invokes the second function, then it goes into the second function and then comes back. If there's no return, your flow of control will simply come back and continue the rest of the main. Remember, your code evaluations happens from left to right, top to bottom, in that order. Let's look at parameters list. You might have noticed that a function name has this parameters list. In our previous example, we have this integer year. This in year is one parameter. Sometimes you can have multiple of them. For example, you can have integer x, comma, integer y, comma, Boolean t, or something like that. This is a parameters list. Now, in order to invoke this function, you can call func and pass in the value, let's say 1, 2, and true in the event where you have integer x, integer y, Boolean t. Now, this 1, 2, and 3, these are what we call arguments. They're not parameters, but arguments are the ones that user specified. So when you pass an argument by value, as in the case of 1, 2, and true, a copy of the argument's value is made and passed to the call function. So inside this function block, this 1, 2, and true is passed by value into this function directly, which means this 4 bytes integer, and then the 1 byte Boolean will be a copy inside of this function. Now, since this value is the same as the original caller's arguments list, these copies have no effect whatsoever to the original value, 1, 2, and true. Now, let's look at this call by reference. This is an advanced topic. In C, in fact, all calls are called by value. Call by reference simply means that you're passing someone else's memory address. So if the argument is a variable, let's say integer k equals 5, and this k sits somewhere in memory already, you're passing this variable's memory address or reference into a function, then this will be true, meaning the caller actually allows the call function to modify the original variable's name. In order to call by reference, we have to make use of either the address operators or indirections operators. This is something that we will discuss later when we get into memory and pointers. By passing a pure primitive data type into a function by way of its value, or simply just doing call by value, a copy of that value is created inside the function, which makes use of those values. Now, whatever those values are, if you change the values inside the function, they will have no effect to the original values outside of that function. That's what we call by value. Just a quick review. If you're to pass an object by reference into a function when you invoke it, we must use the address operator or the address of that object. Or we can use the interaction operators, as in dereference that pointer to get to the object's value. Whenever that object is involved as an argument in a function invocation, that variable is passed into that function by reference. Let's look at this call by value example. We have a function signature that takes an integer argument, which returns an integer. This is also what we call formal parameter. This 5, when we invoke this function, is what we call argument. The other name for it is actual parameter. So when we send this 5 into this function to invoke it, this function takes 5 and makes a copy of it whenever this num is called, and the result becomes 125. And this 125 is returned to the caller. This caller, the R value, is assigned into the L value. And L value is a computer term that signifies this particular object having a memory address. So inside this memory address, the value of this particular variable assumes the value of R value, which is 125. Let's look at pointers next.